Thank you for coming to my talk. My name's Simon Lightfoot. I'm a CTO at Dev Angels London. We're a small developer agency. I do not work for Flutter, first of all, just to clear that up, because there's some confusion where I'm wearing all the Flutter stuff. I also run the Flutter community. There's a GitHub, YouTube channel, and all that kind of fun stuff. So yeah, if you're looking for more information, definitely come find me at the booth or any one of the links that will be provided. What is Another World? It's a play on words on the title, but the original game was built on the Amiga, and it is a cinematic action platformer. It was released in 1981 by Eric Chahi, and it was released in America as Out of This World, so just in case you're wondering what the title change is. It's considered one of the best and most influential games, actually. It opened up the genre for cinematics and sort of full thematic games. The game follows Lester, who's a young physicist, and at the very beginning of the game, he runs a particle accelerator, and he's hit by the actual particle accelerator is hit by lightning, and he's transported to another world, and that's where we get the title. What is the game to me? So back when I was a kid, our first computer, in fact, the one I started programming on, was an Amiga 500, and the plus made all the difference. It gave us an extra 512 kilobytes of RAM, which was awesome at the time. And it had a whopping 7 megahertz processor, which was also really fast at the time. I saw the game. The game art is on the right there. I saw this box on the shelf at a local store. And, I read the back, and you see this lovely artwork, and you expect a game. Those are the days when you expect a game to match the box. No, it never was the case. This, however, was one of those cases. The game is really awesome, and we'll see it in full action soon. The game had a really quite long longevity, and I think that was just because it was sort of those early internet eras, pre-internet almost. So you had to hear from your friends about the game till you go get the game. So yeah. It just was absolutely amazing. I'm going to gush over this because it is one of my favorite games, so apologies. But it took advantage of the Amiga's custom hardware, and they made some custom chips which made this sort of high resolution graphics available at the time. Anyway, he built this awesome masterpiece, and this was his go-to system. The game was actually ported to a lot of other systems. And you can actually go now get it on Switch and things like that. So just saying. Anyway, so recently I read some articles on the game. Some people were reverse engineering the original game code, and I kind of had that urge of recreating something from my childhood. So I want to share that journey with you today about how I recreated this game in Flutter. So we've got a lot to talk about, and I'm going to try and race through it and have time for Q&A. We'll see. I'm not going to read through these titles. We'll see as we go, but there's a lot to talk about. Comparison before and after. I want to just give you this. This is a series of clips. Can I play this from here? Mm-hmm. Why do we not have audio? Well, you're going to have to imagine the audio. So on the left is the before, and on the right is the after. So you probably notice a slight increase in the resolution. It's very hard to see it side by side scaled at this resolution, so you have to go onto YouTube and find some originals, but you'll see there is a difference. There's a definite difference. I'll set up my laptop at the booth if anyone wants to come play the game after the talk, and you can experience it for yourself. I'll let this play. This is sort of a series of clips from the introduction of the game, and I've shortened it for brevity. It's much fun when there's, it's more fun when there's sound, so apologies. So we're going to skip ahead because, there's some good scenes coming up. We'll play it in full in a minute. He says. I pressed the wrong button. So before being the original, and then after being the one that's recreated in Flutter. So the actual backgrounds in the game, the entire game is rendered in vector. We'll get to this now, actually. I won't. So I call this a source port. You just see if you can fix. It's all right. We'll carry on and we'll see if we can get to the sound later. So how is this a source port? The source code was never released. However, because it's so enjoyed by so many people in the developer community, some clever people. I'm going to butcher these names because I'm terrible with foreign names. So, Gregory Monitor and Fabien Selgard. They worked on reversing the original game, and so I've taken their efforts at reversing and ported it to Dart and Flutter. So yeah, this is not something amazing. This has been done before. There's also Becky Heinemann. She goes by the name Burger Time Becky on her live streams, and she actually ported the original SNES 3DO Apple IIGS and all those early ports. And there's also another talk by Eric himself at GDC, Game Developer Conference, and there's a post-mortem on the game. There will be a link to the slides at the end if you want to get these URLs. And yeah, as I said, without their reference, this wouldn't have been possible. So, how did the original game work? So there's no sprites. It's fully vector drawn. It's the processing power at 7 megahertz to try and get a full, it was 30 FPS game, this is 10 years before the SVG standard was released, right? This is revolutionary stuff at the time. It does store it stores the vector information in as small as possible, and the entire game fits on one floppy disk, 1.44 meg. Try and make your apps now fit that size. We're going to talk about a few things about how it was done. So the game was dropped to a reasonable resolution, so 320 by 200 at the time. That was considered a reasonable resolution for games, and 16 colors. And you'll be surprised how 16 colors can get you quite far, actually, when you swap palettes and so on. But just dropping the resolution in the colors was not enough to get that full 30 FPS. So Eric used some of the hardware features of the Amiga, the processors called Fat Agnes, and the original coprocessor did 2D hardware acceleration of graphics. And we're going to talk about a few bits here. So the picture on the top right is some bit planes. It was expensive and it still generally is expensive, DOS and other layers, is to switch between those bit planes is a hardware thing. So it takes some time. So there's some tricks you can do in terms of how you process those. I won't go into the details because this is about the Flutter stuff, but it's quite amazing. But it's interesting. You can make instead of switching the bit planes, you can actually redraw the polygons at a quarter of their speed. So basically, you get a 4x increase in doing some tricks that he does. So that actually gives him just enough to get that 30 FPS. And the CPU is also doing all the rendering and the game logic. So, it's quite a lot. Each polygon is actually drawn to a scratch buffer and then filled using a flood fill algorithm, as pictured in the bottom right here. And then the whole vector that's been drawn in scratch buffer is copied to the screen memory. This kind of enables in the old games you might see the actual CPU drawing the pixel on the screen was not fun. So this sort of bit block copying is actually more efficient. So, but still, how does this achieve with many hundreds of polygons on the screen, right? So he decided to do multiple frame buffers. So this is basically I think if I remember rightly, it was 50 polygons per frame he could render at 50 FPS, but still not enough to get like the graphics that he wanted on the screen. So he implemented double buffering, where each of the computers displays one frame whilst it's rendering to another, and then if you pre-rendered your background to another buffer, whenever you need to re-render the screen, you just copy that to the screen and then make your changes on top. Pictured here, the purple is the background, and the text is added in the red buffer, and then that's finally copied to whatever top buffer is not being displayed, and then it's switched to the screen. All that copying is done with a DMA, that's direct memory access. That's the hardware process on the board itself, which was very efficient. So, I mean, it took him, I think it was 2 years to build the game, one person. And, you know, when you get to a point where, you know, you can't just handwrite these things. There was no tools, there's no SVG editors, there's no Adobe. So he had to make his own graphics editor, and he made a polygon editor in GFA Basic. These are some screenshots from the editor itself. And he built his own custom vector format and custom keyframe format. And the editor as well. So this is one of the things I did want to mention. The power of the Amiga was its support for an external genlock. This is an external device you plug into the Amiga. And it's actually what was used in all the weather channels and all the TV channels when they had like the banners that scroll across the screen and all that kind of fun stuff. And this allowed the people that ran the software to actually play stuff on top of video. However, during development, you can also display the actual recording. In this case, he made a paper cardboard gun, videoed himself, played that into the computer, and then traced that out on top using his vector software. These were actually placed on top. I don't have a screenshot of that, I'm afraid. But I remember playing with this myself when I was a kid, so it was really fun. This was, and it is called rotoscoping, and it's now used all the time in modern VFX, right? This is bread and butter for VFX artists. Yeah, let's move on. So the original game had a scripting engine. This is also what's made it possible for me to port it. The original obviously would have otherwise been written in 6502 or 68K assembler, I forget which processor. So the entire game is written in this custom virtual machine scripting language. And the VM itself that it runs on was written in assembly language and totaled 20 kilobytes. And this is what actually made it also possible, because that is the bit that was reverse engineered. So, you know, try and reverse engineer any huge piece of software, this is not possible. But 20 kilobytes, that's doable. So, the actual VM has 256 variables, global variables, that's it, and 27 instructions, and the ability to run multiple tasks. And the method that he chose to use is called cooperative multitasking, if you're interested in that kind of stuff. And this is also similar to the way that, I'm going to say this now, similar to the way futures in Flutter work with async and await, very similar. So the code can start one task and one of the 64 slots, and then we'll get a portion of the processor's time in the next frame. The Flutter recreation, I will have time to answer questions at the end. So we use all the original game data. To recreate all those original game assets would have taken just as long as Eric in the first place. I'm not going to do that. So instead I've made a little parsing engine that parses the original game data files and then loads them into Dart, into models. We'll talk more about that in a bit. And basically, we take that vector information and display it in Flutter on a canvas using standard paths. So this is also possible in Android. Any of the sort of standard canvas APIs, you'll be able to do this with. But you know, how do we know where to place these polygons? How do we know where to animate them? So the virtual machine itself, I create a ticker, which is a platform feature on Flutter to essentially tell me when a frame is requested for by the platform. And then we loop over each of the tasks in a continuous execution of the bytecode, and then until each task yields. So that's cooperative multitasking. So a task does what it needs to do, and then it yields back to the main game loop to run another task. And the actual opcodes, there's an example of processing some of the actual opcodes in Dart code there. The upper 2 bits of the opcode actually allocate more than half of the instruction set just to drawing polygons at certain offsets. This kind of just made it more efficient to store the bytecode and so on. This is the full set of opcodes that are implemented. Yeah, I mean, like, it's just a simple map in Dart, and I can go through the code in hopefully in a live segment. Yeah, it's pretty straightforward. Most of these are the standard operations you might find in a processor: move, set, copy, and or, so on and so forth. Yeah. There is a few here that are unique. So we've got some set vector, which is creating a new task, reset the current task, set the palette, and then we've got copying pages, that's those frame buffers we saw earlier, and then draw string and play sound and so on. These are just make it a bit more efficient. Each of these instructions change the local state of the original game, as same as the original code. There's no real change here. Something I came across actually for the first time in this was a lot of the integers in the original are 16-bit. So since we don't do 16-bit anymore, to create signed integers, there's actually a toSigned method, which I don't know if I'm using on this slide here. Nope. But on an integer, you can actually, is it on there somewhere? Oh yeah, toSigned 16, there you go. And what that does is that sign extends. So that takes the high bit and then extends it out to the rest of the 32 or 64 bits, depending on the integer. And the local variable manipulation that's been used is just the standard stuff in the game. Track the game weapons, charge, player position, the usual. And then these are also used to track positions of things that you want to draw on the screen, and that's what we sort of lead into next, drawing the polygons. So the original game used raw pixel buffers at 320 by 200. That's all fine and well, and we can recreate it at the original resolution with the power that we have now and the processors, and that's all fine. However, to do that at 4K, suddenly trying to get even software rendering at 4K on a modern processor is still quite a lot of effort. This is why we have GPUs. So I want to take full advantage of the GPUs, and we'll lead on to that in the next slide. But each color in the original is represented by an index into the 16-color palette. Each of these images has the 16-color palette underneath. And there's a lightning strike you missed at the beginning, which all it does is it manipulates the palette. It makes a bunch of the colors white, a bunch of colors black, and you're going to get this effect. Sadly, we obviously can't do that. So if we're not using palletized graphics, we're not drawing per pixel, we had to find alternative solutions. Also, the original game, the original author wanted transparencies and effects, and you just can't do that with 16 colors. You just don't have that ability. So he actually aimed to do a quick change, and that is set the topmost bit in the palette index, and for each pixel, and that would half the palette to 8, but it would give you an alternative 8 colors, and that's what we see at the end here. So you can see the headlights of the car. For those pixels, he just shifts the palette down to the bottom, to the upper 8 colors, and that achieves this kind of transparency effect. Yeah, and I think doing all of this at high resolution, we'd probably get 10 FPS if we want to do it in software at 4K, if we're lucky. So what can we do about that? So drawing polygons in Flutter. So Flutter recently added support what's called a fragment program, which is fragment shaders. It's great to have that, and it offers some cool effects and some things you can do. My initial hope was, for when I was building this, was just to ship all the data across to a shader, and I'll do it all in the shader, and problem solved. Sadly enough, the actual way that fragment shaders work, they have a limited set of floats that you can supply to them, and they're fixed in size and some other things. The way that you would solve this in modern shaders and GPU work is that you would define a texture, and that texture actually holds data. And then you pass that reference, that texture, to your shader, and it can load the data from there. And again, sadly, in Flutter, images are immutable. So once you declare your pixel bytes for your image, and then you convert it to an immutable image, and then that's shifted off to the graphics card. Doing that on every frame, again, means you're now doing pixel manipulation. You're not taking advantage of the GPU. So what can we do? So I think I mentioned here, yeah. So the only way to kind of do this is this decode image from pixels. So if you are actually trying to do anything with pixel manipulation, that's a global function in Flutter that will let you decode raw pixel RGB data and store it as an image. There is actually an issue up to track this. So please, if you want to fight on my side, go thumbs up 37180, and maybe we'll get this a new feature. So with all these limitations, how do we approach this? Display lists. So it's not unknown. I mean, Android uses display lists. All modern UIs use display lists, and it's how most 3D acceleration works in modern times. So you're basically recording a series of commands. Those commands are then replayed on the GPU. So I've replicated this concept in my port. Each buffer that you saw on the screen earlier has a display list attached to it, and we record the actions that the game performs. When it says draw polygon, we take that polygon and store it in a list. And this ends up being using what's called the painter's algorithm. This is just like one drawn on the other, drawn on the other. So there is potential for pixel redraw and a pixel overdraw, sorry. But I think it's still pretty efficient. And then later on, we then take those commands and we replay them to the Canvas API to actually display it. We're essentially doing a double display list here because the Canvas actually records those commands that you run on it. They get sent off to the GPU as part of Flutter. Interestingly, the original game has a screen shake effect, and in the original, it would copy the entire pixel buffer down by one and up by one, or however many pixels to kind of get this vertical shake effect. Well, for us, we just say move and translate. So it's like canvas.translate up by 10, down by 10, or whatever, and it's just so simple. I was dreading this, and it just turned out to be really simple. I'll go through some of these commands. Yeah, as you can see on the right here, that's the shift vertical, fill screen color. These are sort of basic commands that you might receive from the engine. Draw polygon, and this index is where it's stored in the buffers. And then update the display takes all those commands and asks in the original code it would be flip the buffers and show it on the screen. We just shift it over to Flutter to display it. I'm going to move on here because I do want to get to a demo with plenty of time for questions. Sound effects and game music. Sadly, in Flutter, we don't have sound as a feature built in. It's meant as a UI framework. Sound is not part of UI apparently. So there's no built-in system in Flutter. So you can always use a plugin or a package, and there's several out there. For what I needed and the time span I had before the talk, I decided to try a few different other things. So since I was building this for Windows initially, I thought I'll use Tim Sneath. So Tim Sneath, the product manager at Flutter and Dart, and he made a package called Win32. He comes from Microsoft, so he knows all the APIs, and thought, oh yeah, if you want to do anything on Windows, use the Win32 package. I highly recommend it. However, to use the core audio APIs on Windows and to go low level is going to take some time. So, and I also knew that there's people I know with Macs, so they want to use it. So, what can we do that's multi-platform? So, I don't know if anyone here has tried to make cross-platform games, but there's a common library called Simple Direct Layer or Simple Direct Media, something like that, SDL, and it's been around for ages. It's open source. So what I've done is used Flutter's FFI feature, foreign function interface, and that allows us to speak directly from Dart to C code. So I'm just calling the SDL APIs and telling it to play back audio, mix the audio, and so on. So it's a bit of a cheat. It's not totally done in Flutter, but it's nice. It works, and it's cross-platform. Let's move on. Drawing text. So in the original screens, we didn't see all of it, but in the original screens, there's quite a bit of text that's displayed throughout the game. And the original game made use of an 8x8 pixel font. And what the original game would do is just process the bitmap font. When it gets a 1, it draws a pixel. When it gets a 0, it skips that pixel. It's a standard thing for drawing bitmap fonts. But we can do better, and we want it to be high resolution. So there's actually an API on Canvas in Flutter called Draw Atlas. Basically, you supply one image, and you tell it to take source portions of that image and display it in multiple places on the screen. This essentially allows us to render all of the characters of text for a frame in one API call, right? One GPU call. Here, you can see here, like that's the entire function. It's a bit small on the screen, sorry. But yeah, it's pretty straightforward. There's nothing amazingly complicated about it. Demo. Let's get to the good stuff. Let's see if I can make this work. I'm hoping the sound works, but if it doesn't, of course it doesn't. Let's give it one last try. Should be playing. It was earlier. No. Wow. Oh, the fun. Well, you're going to have to experience it without sound. Sad to say. So this is the game running in Flutter. So there's an introduction to the game. I'm going to stick this in debug mode. These are the 4 frame buffers and displaying each of the display lists. And let's skip forward to some gameplay. There's an interesting ripple effect. So this is all vectors drawn from the original game. There's still a few issues, but for the most part it works. So this is it. This is the game working in Flutter. Here's that screen shake effect of the game. Hopefully it's going to do it again. Maybe. This is so much more nicer with music. I promise. Music and sound. It's a shame. No. Never mind. Basically everything in this game is out to kill you. This is how you die the first time. Always in the game. We'll restart that quickly. I have all the magic hotkeys. For example, if I don't swim up, there's a monster in the deep that's going to pull you back down. Everything is designed to kill you. I'll be quick here. The many times I've played this. Come closer. Hopefully this doesn't bore you too much. We'll get to a good bit. Some actual proper gameplay. Everything will kill you. Oh, they're just out. Why? It's so interesting. It's so exciting.
It's really exciting to see how you kill these things because I played this as a kid. They never passed.
And this thing will kill you if you're not careful. And you can see how this was right at the time. There was these were all Space Invaders and that kind of arcade game, and to have full motion game like this, full cinematics, it was just there's always so cool sounds. Sorry, was absolutely amazing. Thanks for saving me. Hey guy. Luckily, I'm only stunned. That's the segment. That's the first segment. We'll go for a little bit more, just to show you how this is. It's all game, just the cinematics, just to have these frame changes and to have this kind of. His irises are moving. It's amazing. He was as a kid, anyway. How do you do this blur effect? It's so cool. So this is another bit where everyone gets stuck, which is you have to move left and right to move the cage, and eventually it actually makes these sounds, so you know that it's time to move. Hopefully, in a second, it will. Yeah, the guy down there complains that You should not be. He actually just says a weird alien language, but don't do that. Stop doing it. And yeah, goodbye, mate. And then you're the prisoner. Thanks, mate. Thanks for getting me out. And then this is that. There's that sort of full rotoscoped action. I've done this way too many times. Die. So you hold down the fire button. It's really simple controls. You hold down the fire button, and you generate shields. And so does the enemy. And if you hold it down for a little bit longer, you actually generate like a blast. You have a certain amount of energy in your weapons. There is a bug in my version of the game which doesn't display the screen very well, so apologies. There is a fancy lift here. In fact, do you know what we can do? Turn on high-resolution backgrounds. Yeah. Yeah, that guy. There's a little hint here. There's little lights at the bottom of the screen there to show that the doors down there have power. And if you're very clever when you're a kid, you go down here. You kill the power. The lights go off. And come on. Come on. Kill. This took hours to figure out, when you first played the game. Oh, no, I've run out of power. Uh-oh. I don't have a way of charging this at this side of the game. This is how you die and just start again, so we won't be doing that. What I will do is go to the next section because I can cheat. Next one. So when you go past that screen, the guy opens up a little hatch for you, and you fall down into these underground tunnels. Now I'm going to show you the debug mode here because you can see the original background, which is pre-rendered, so because you can only render 50 polygons per frame. Then they take that background per frame. This one gets made, and then the Steam vents get put onto that, and then the final copy takes a section of that screen and puts it into the display buffer. So yeah, if you die, obviously, everything kills you. And let's turn this. That's easier. I can see what I'm doing. Without sound, this is going to be really difficult. We'll see. We're not here to watch me play the game, but I'll just show you a few of the other effects. Oh, have I gone the right way? I don't know. I think so. If you go the wrong way, you just fall and die, and like, everything kills you. And this is where I get to charge my gun. Yeah. Oh. Luckily, I have infinite charges. And I'll just go for them a little bit more, and then we'll get back to the slides. So much better with sound. Okay. Well, oh, I made it. You fall and die, obviously, if you don't make the jump. But yeah, there's just so many scenes and things to visit in this game. I've played this way too many times. Oh, there we go. I die. All right, that's that. Yeah, so there's you can skip to any one of the scenes in the game and sections, and this is actually the very end of the game. Am I spoiling it for you? You should go play it. You eventually crawl across. You're at the top of the tower where you kind of leave, and yeah, you're trying to get to the end, and then your friend comes and saves you. Anyway, that's the end, right? Blah blah blah. In the original game, I will just mention in the debug we do actually have a bunch of like really cool sort of like debug things where we can see the borders of all of the vectors. This was helpful for debugging. And there's also sound, and we can pause the engine at any point to take screenshots and things like that. Fun times. Right. I do want to mention, where you can get the original game from. It's currently available on Steam, GOG.com, and on the Nintendo Switch. Please support Eric. He's done amazing work, and all that time ago, and it's still awesome now. If you want the source code, or you want to play it yourself, you can go download it from my GitHub, another Dart there. And if you take a picture of that very QR code, you'll get a link to the slides and all the content there within. If we have a couple of minutes, we can do some questions, I guess. Sorry. It's too much fun playing games. Any questions? I don't know if there's a microphone, so I will repeat the questions. Go for it.
The physics of this game, is it that you just parse the source file, the original bytecode from the source file?
Yeah, so I'm not recreating any of the game sort of behavior or logic. It's all original. This is one of the things I wanted, because I wanted as close to the original as possible. And just by making the VM engine, it then handles all that sort of velocity changes in game logic and input and so on. So input from the keyboard, I hand off to the VM, changing the appropriate bit fields, and then it sees that key has been pressed. And
It's still very impressive.
download it and check it out. It's not too big. It's quite amazing what you can do with Dart and Flutter. Yeah. Go for it. It was about 2 weeks of evenings, I think. It was about that, yeah, and a couple of weekends along to boot, and a mad race before. It wasn't this. I gave this talk at Flutter Vikings about a month ago, so it was just before then. So yeah.
So the original engine, basic, was it available, the source code?
So the original source code is not available. However, a couple of people in the community, in the wider developer community, have already reverse engineered it and have written it in C. And so what I've done is I've taken that C stuff. It's very raw, so I've rewritten that in Dart. And it also kind of Dartified it, if you will, kind of made it more sort of friendly to Dart. I think there's a lot more I could do, given some time, so I kind of do want to spend some more time tidying it up and doing some nice, just clean up a bit. Any other questions? Yeah?
Is your part of the game just available on Steam?
No. So just be clear, the original game and includes the high resolution graphics. They in 20 something. Sorry, they redeployed the game and they updated the graphics on it, so you can actually get it. And they've done a very similar thing. You've got high resolution backgrounds and high resolution vectors. So if you don't want to play it from my repo, you can play it on your Switch. There you go. Is that it? Great. If you want to play the game and hear the sound, come by the booth, and we'll go from there. Thanks.